How does your computer's operating system actually boot? Imagine turning on your computer and watching it come to life, ready for you to start working or playing. But have you ever wondered what really happens behind the scenes to make that happen? When you press the power button, a complex process kicks off that prepares your computer for use. It all begins with the hardware receiving electricity, which then signals the system firmware to take charge. The firmware, which can be called BIOS or UEFI, performs a quick health check called the power on self-test. It checks if the memory, disk drives, and input-output devices are working properly. If something is wrong, it will alert you with beeps or messages and stop the process. If everything checks out, the firmware looks for a boot device, like your hard drive or USB stick, based on a list stored in memory. It then reads the first part of that device, called the boot sector, which contains a small program called the bootloader. The bootloader's job is to find and load the main part of the operating system, known as the kernel, into your computer's memory. Different operating systems use different bootloaders. For example, Windows uses the Windows Boot Manager, while Linux often uses Grub or Lilo. If you have more than one operating system installed, the bootloader might show a menu so you can pick which one to start. Once the kernel is loaded, it begins initializing the core system components and hardware drivers. These drivers help the operating system communicate with your hardware devices, like your keyboard, mouse, and display. After that, the kernel starts system services and user processes, which eventually lead to your login screen or desktop. The main differences among operating systems are in how they handle the bootloader, initialize the kernel, and manage system services afterward. Windows uses the Windows Boot Manager and NT kernel, while Linux uses Grub and the Linux kernel with systemed or init. macOS uses a version of UEFI and a bootloader integrated with its own kernel. Knowing how this process works can help you troubleshoot startup issues or customize your system's boot behavior. Every step is designed to get your computer ready for your commands, making sure hardware is working and the software is set to go.